This video is going to explain why refraction happens. Okay, so as you can see in the diagram, what I've done is I've drawn what you would see if you had a light underneath some water. So the bit where the light is representing the bits where the water is the shallowest. The bits in the middle are where the water is the highest. So what you've actually got is a wave that is coming down here, going up, going down. So you've got a pattern over the top of this wave. Okay, so if you look at the image that I've got over the top of this one, you can see that the bottom, this is what the wave would look like side on. Okay, so the bottom of the wave side on, the water wave moving this direction, is actually in line with the light bits. So the light bits are the bottom of the wave, the dark bits are the top of the wave. So the wave is moving in this direction and it's being generated over here by some moving object to make the water wave move. So the wave is actually moving in this direction. You'll see that when I turn on the image. But what I need to do first of all is talk about a couple of things. The first one is the frequency. Because these waves are being made by the same object, they'll all be made at the same rate. So they will have the same frequency. Okay. The red line shows you the direction the waves appear to be moving in. Okay. So you've got deep water this side and you've got shallow water this side. Shallow water means there's more friction on the bottom of the wave because the water is shallower. It's nearer to the bottom of the container. Therefore, there's more friction, which will make the wave slow down. So in this part of the water, the wave is moving slower than in this part of the water. Okay, so something's going on at the surface. This wave is all one wave. So a couple of seconds earlier, this would have been a straight line. So something has happened here to this straight line from over here to make it bend. So when I turn on the animation, we'll be able to see what that is. So as you can see, the waves are coming along and they're moving quite quickly. They're hitting the surface and over here, they're moving much slower. So the speed change is the reason we get a direction change. This end of the wave at the top, these ones, are always hitting after the bottom bit of that wave. Okay, so that means that this end of the wave has slowed down before this end of the wave does. So this end of the wave overtakes, this end of the wave slows down. Because it's doing that along the entire surface of the division between the deep and shallow water, it's doing that all the way along. So the top part of this wave has always traveled further than the bottom part because it was traveling faster the same amount of time in the video. Okay, so what does this mean? Well, the wave speed is changing, okay? But all the waves are being made at the same rate. So something else must be changing. What is changing is something called the wavelength. So if I pause the simulation, you can see that the distance between the bottom of the wave fronts, the bottom of these lines, the bottom part of the wave that I showed you earlier, is actually farther apart here than it is here. So the frequency of the waves stay the same as they move through the surface, the wavelengths change, and the speed changes. So the speed gets lower, so the wavelength has to decrease because of that effect. So you always end up with a smaller wavelength going into the surface, but the frequency stays the same across the boundary. So the waves are always coming at the same rate. It's just here they're now traveling slower than they were over here. So at a grey boundary, between the two things, the speed of the wave changes and the wavelength of the wave changes. And that's why we get the bending, because this side, that the bottom, is slowing down before this side, and this front side at the top overtakes the side at the bottom.